Hello, I Neha Dikshit going to explain you today introduction to chain drive. In previous part of introduction of chain drives, we already seen introduction of chain drives, advantages, disadvantages, limitations of chain drives, and geometry of chain drives, also polygonal effect in chain drives. In this part, we are going to see modes of failures in chain drives, and major part is selection of chain drives from manufacturers' catalogs and methods of lubrications of chain drives. Now, next topic is modes of roller chain failure. There are four modes of roller chain failure. First one is fatigue failure of link plates due to tension, fatigue failure of rollers and bushings due to impact, wear failure of pins and bushings, galling of chains. First one is fatigue failure of link plates due to tension. As the chain passes around the sprocket, it is subjected to tensile force, obviously, which is varies from maximum on tight slide and minimum on slack side. And this may lead to fatigue failure of link plates. Second mode of failure is fatigue failure of rollers and bushings due to impact. The engagement of roller with teeth of sprocket takes place with impact. There is no smooth operation. This may lead to breakage of rollers or bushing. Lowest of two values, that is kWL, it is the power rating of link, and kW of R, it is the power rating of rollers, that is the power rating of chain at that specified sprocket speed. That means you have to select from power rating of link and power rating of rollers which one is the lowest value. Next mode of failure is failure of pins and bushings. The wear of the pin and bushings result in elongation of chain. This increases chain pitch, that is small p. As time goes, chain pitch grows so large that it fails to match the sprocket teeth and chain may run off the sprocket. Fourth mode of failure is galling of a chain. Galling is a stick slip phenomenon between pin and bushing. When heavy load and high speed condition is there, welds are formed at high spot of contacting area between pins and the bushings. These welds are immediately broken due to the relative motion, which leads to excessive wear even in presence of the lubricant. So to avoid galling, load on chain and speed of a chain should be less than the specified value of the manufacturers. Before going to selection of a chain, we will see power rating of a chains. Now what is power rating? Power rating of a chain is the power transmitting capacity in kilowatt of chains given by manufacturer's catalog are based on following condition. First condition is the number of teeth on driving sprocket is 17. The chain has single strand, and last condition is the life expectancy is 15,000 hours. Now we will move to the selection of roller chains from manufacturer's catalog. There are several steps to select chain from manufacturer's catalog. First one is the data available. Data available, it may be power to be transmitted, input and output speed, and sometimes center distance is given. So second step is select the number of teeth on smaller sprocket, that is the sprocket pinion, and depending upon speed ratio, that is suppose speed ratio is 1 to 2, then number of teeth on sprocket pinion, that is Z1 is 30 to 27. If suppose speed ratio is in between 2 to 3, number of teeth on sprocket pinion, that is Z1 is in between the 27 and 25. Next, third step is select service factor or load correction factor denoted by KS for given application. And next step is calculate the design power, that is capital PD is calculated by service factor or load correction factor into given power, capital P. Now next is find the tooth correction factor, that is K1. As explained before, power rating of a chain given by manufacturer's catalog are based on condition, that is number of teeth on driving sprocket is 17. But in actual condition, number of teeth on driving sprocket can be less than or more than 17. Tooth correction factor K1 accounts for this. So knowing the number of teeth on driving sprocket, select the tooth correction factor from the following table. For example, suppose driving number of teeth on driving sprocket is 14, then tooth correction factor K1 is 0.78. And suppose number of teeth on driving sprocket is 23, then tooth correction factor K1 is 1.35. Next step is find multiple strand factor, that is K2. Again, as I explained, power rating of chain given by manufacturer's catalog are based on condition, that is chain has single strand. In actual condition, multiple strand may require. So K2, that is multiple strand factors, account for this. So knowing number of strands, select multiple strand factor from the following table. Suppose number of strands are 1, then multiple strand factor is 1, 2, then 1.7 and 3, then 2.5. Next step is calculate required power rating of a chain. Uh, See, it is a power rating of a chain required. We are going to calculate, and it is given by PD divided by K1 into K2. PD is the design power divided by K1 is tooth correction factor and K2 is multiple strand factor. Or power rating of a chain is calculated by Ks into P. It is a PD divided by K1 into K2. Next step is select chain from manufacturer's catalog having required power rating, which you have calculated previous step. And next is find the dimensions of a selected chains from. Next, find the number of links in chains, that is capital M. You already know this equation where P is the pitch, Z1 and Z2 are the number of teeth on driving and driven sprocket, and C is center distance. Suppose center distance is not given, and then you have to calculate the correct center distance from the following equation. And find the minimum theoretical power that chain can transmit based on its tensile strength. It is a minimum theoretical power that change can transmit. So it is calculated by P max is equal to FB into V divided by 1000. It is in kilowatt, while FB is the breaking strength of the chain and V is the average speed of the chain in meter per second. Now, as we know the limitation of chain drive, that chain drives require periodic lubrication and slack adjustment for the smooth operation. So lubrications are necessary for the chains. Chains are lubricated by light or medium mineral oils like SAE 30, SAE 40 or SAE 50. Following are the methods of the lubrication. First one is the manual lubrication. If chain speed is up to the 0.5 meter per second, then use manual lubrication. If chain speed is between 0.5 meter per second to 1.5 meter per second, then use drip lubrication. Here oil drops are directed between the link plates. If chain speed is between 1.5 meter per second and 5 meter per second, then use oil bath lubrication. In this, lower strand of a chain runs through the oil sump and carries oil with it. If chain speed is above 4 meter per second, then use oil stain lubrication. In this, oil is supplied under pressure by external pump inside chain loop on lower strand. Thank you for listening.